In this video, we're going deep into dopamine production, the dopamine synthesis pathway, and the raw materials and cofactors that make dopamine possible. Tyrosine, BH4, iron, and vitamin B6. Dopamine production is a simple chain. Phenylalanine to tyrosine to L-DOPA to dopamine. And what people miss is that the chain doesn't run just because the ingredients exist. It runs because the enzymes have what they need. And the key constraints are often BH4, iron, and vitamin B6. So in this video, I'm going to take a different approach. I'm going to treat dopamine like a real biological supply chain. Precursors, enzymes, cofactors. And I'll show you exactly where that chain can slow down. I'm Dr. Sanil Rege, consultant psychiatrist and educator. I've developed several psychopharmacology courses on the Academy by PsychScene. And what's important in psychopharmacology is recognizing the full chain from biochemistry to the medications and how we use them. By the end of this video, you'll have a clean mental model you can use. And I'll answer the question everyone asks. Should I supplement? Not in a way that's generic, but balanced. Quick disclaimer, this video is educational only. It's not to be taken as professional advice. So when it comes to dopamine, the topic usually gets presented in two unhelpful ways. One version turns dopamine into a trend. Optimize your levels. The other version is pure biochemistry with no clinical translation. I'm taking a third route, a clinician's map. Here's what you'll get. 1. What dopamine is built from. 2. The two enzymes that do the heavy lifting. 3. The cofactors those enzymes require. And how to think about symptoms and blood tests without turning it into chasing supplements only. So let's start right at the beginning. What dopamine is made from. The simplest question that we start with is, what is the brain building it from? Dopamine is synthesized from amino acids, specifically phenylalanine, which can be converted into tyrosine. So tyrosine is the main direct precursor. The foundation is dietary protein, digestion, absorption, transport, and then availability. That sounds basic, but clinically it matters because a surprising number of dopamine-like complaints sit on top of inconsistent intake, irregular eating patterns, appetite suppression due to stress or stimulants or illness, or diets that are technically healthy but low in protein across the day. Now this is where people may misunderstand what I'm saying. I'm not saying protein fixes dopamine. I'm saying if you're mapping dopamine synthesis, this is the first gate. So if tyrosine provides the supply, what actually converts tyrosine into dopamine? This brings us to the production line. 2 steps that matter. So here's a way to conceptualize this. Dopamine synthesis is like a production line with 2 major machines. Machine 1 is tyrosine to L-DOPA. The enzyme is tyrosine hydroxylase. This is a step to remember because it's the rate-limiting step in catecholamine synthesis. Machine 2, L-DOPA to dopamine. The enzyme required here is AADC, which is aromatic L-amino acid decarboxylase. This requires the active form of vitamin B6. So the pathway looks like tyrosine to L-DOPA to dopamine. And the cofactors required here, tyrosine hydroxylase and the active form of vitamin B6. So when a patient comes to us and says, I feel flat or my brain's foggy, I'm tired, it's important that we step back and also ask, are the machines running and do they have what they need to run? So that brings us to cofactors. So we saw earlier that for the production line to work properly, we had 2 enzymes, tyrosine hydroxylase and AADC. Now the thing about enzymes is that they aren't just present or absent. They're dependent on cofactor availability. So here are the important cofactors. 1, BH4. This is tetrahydrobiopterin. For tyrosine hydroxylase, which is the rate-limiting step, BH4 is an absolutely essential cofactor. It matters because it sits right at the front of the line. So if BH4 availability is constrained, throughput production can fall, even if tyrosine intake is fine. We'll touch on BH4 shortly. Number 2, iron. Tyrosine hydroxylase also requires iron for its activity. Here is a video where I explain this in more detail. Clinically, this is where discussions become sort of too simplified because iron isn't a single number. Hemoglobin can be normal, while iron stores or iron handling are not optimal for certain individuals and contexts. I'll come back to practical interpretation later. And number 3, we have vitamin B6. For the final conversion from L-DOPA to dopamine, AADC requires PLP, the active form of vitamin B6. Now that we've looked at supply, then the production line and the machinery, and the cofactors that help the production line function well, we now come to recycling and maintenance. This is about understanding how cofactors can become vulnerable under stress physiology. So let's start off with BH4. You see, BH4 is not a static resource. It cycles between reduced and oxidized forms, and it's very sensitive to oxidative stress. So oxidative stress is high when physiological or psychological stress may be significant. And vitamin C shows up here in a specific way. It is involved in recycling BH4, and it supports the availability of BH4 for neurotransmitter synthesis pathways. The larger point isn't take vitamin C. The point is these systems are interconnected. Under chronic physiological strain, throughput can become less efficient without one lab abnormality. There's also discussion about the role of folate pathway enzymes interacting with BH4 recycling, regeneration, which is another reminder that these pathways don't live in separate silos, they're all interconnected. And what I don't want to do is to overcomplicate it. So what I'm going to do is move it to a mental model that you can actually use. So we're simply going to look at this: substrate, the gate, and the throughput. First, substrate. Do we have the starting materials? Phenylalanine, tyrosine, and we know availability is shaped by diet. Intake is then shaped by digestion, appetite, pattern. Number 2, the gate. What is the rate limiting step? We know tyrosine hydroxylase sits at the gate. And third, throughput. Does the gate have what it needs? BH4 and iron. And what does the final conversion step need? That's pyridoxine, B6. Now, what this understanding does is it stops us from treating dopamine like a knob, up, down. It helps us understand dopamine within a system. So here are the practical clinical implications. Clinical symptoms such as cognitive fatigue, poor initiation, low reward responsiveness, attentional instability, these are not dopamine-specific symptoms necessarily. These can show up in ADHD or depression or sleep disorders, burnout, inflammatory states, trauma-related disorders. So the goal isn't about diagnosing low dopamine. The goal is to understand and formulate. Second, normal hemoglobin isn't the end of the iron conversation because serum iron is not equal to brain iron. Importantly here, iron studies should be carried out, and clinical interpretation requires judgment, context, and caution because too much iron is neurotoxic as well. Third, B6 or pyridoxine relevance is enzymatic, and we know that AADC is dependent on the active form of pyridoxine, but B6 fits into bigger contexts: restrictive diets, malabsorption risk, alcohol use, and medication interactions. And importantly, supplementing pyridoxine and excess pyridoxine can be associated with peripheral neuropathy. So this is not something that should be taken lightly. And number 4, BH4. BH4 is required for the rate limiting step, but becomes expensive under oxidative load. This is why overall stress management becomes really important. So at this point, you might ask, well, should I supplement? Here's how I answer this. Sometimes, yes, but never generically, because supplementation only makes sense when it's guided by symptoms, blood tests, and clinical context. You can explore my videos on supplementation here. A guide to supplementation might look like: step 1, start with a phenotype. What's the actual picture? Are we looking at ADHD with sleep disruption and restless legs? Are we looking at appetite suppression, irregular intake, GI symptoms, inflammatory load, heavy menstrual bleeding? Step 2, use blood tests as guides. So if you're thinking iron, don't just Yes, carry out a proper iron panel and discuss it with the doctor. But at the same time, recognize that blood tests may not equate to brain iron levels. This is why a more detailed discussion with the doctor is necessary. Step 3, if the risk is low and the deficiency is plausible, you may consider a trial of supplementation. But it should be implemented as one change at a time, a clear target symptom you're tracking, a review point, the duration, and an exit plan if there's no benefit. And step 4, important to know when not to self-supplement. For example, if you've got bipolar disorder risk or epilepsy or on anticoagulants or on multiple psychotropic medications or are pregnant, it's important to seek medical advice. So if there's one thing I'd like you to remember, it's this. Dopamine isn't a level. It's a production line, substrate, gate, and throughput. And the gatekeeper step requires BH4 and iron, while the final step requires active B6. So the aim isn't to chase dopamine. Build a map, a chain, inputs, conversions, constraints, and then link it to function and clinical context. I'm Dr. Sanil Rege, and this is Dr. Rege channel, where we convert neurobiology into clinical reasoning. And if you're a clinician wanting deeper frameworks about how to integrate neurobiology, biochemistry with phenomenology, sleep, arousal systems, ADHD management, depression management, and medication decisions, have a look at the Academy by PsychScene. If you liked the video, hit the like button and subscribe to our channel. Until next time, stay curious. Bye-bye.